Well, good morning, good afternoon, or good evening, Algebra Geometry 3 classes. We just finished up Unit 9. I know with not taking the EOC this year, usually we do Unit 6 at the end of the year, but we will go ahead and actually now come back and pick up the unit we skipped earlier in January right now, and then we'll finish up with Units 10 and 11 after that. But Unit 6 is going to involve a concept that is called absolute value. Today, in 6.1, we'll actually be solving absolute value equations. But for starters, absolute value, the definition for that is it's the distance a number is from zero. And one of the ways I always like to kind of represent that is if you have a number line, and we put 0 on our number line, if I put 5 and -5. Well, from 0 to 5, it's 5 units away from 0 in a direction going to the right. -5 is also 5 units away. If we put in hash marks here to even represent that, the only difference is -5 is 5 units to the left of 0. So that's what that definition is talking about. Now, if you have an absolute value equation where absolute value is represented by, basically it looks like 2 bars around an equation where we have ax plus b equals c. If you're working with absolute value equations, there will usually be 2 solutions. We have to solve ax plus b equals c, or ax plus b equals -c. Now, if c is negative in the original equation, there is no solution. We'll actually go over an example or two with that here in a few moments, but the absolute value of a quantity is always positive or 0. It doesn't mean your answers can't be a negative or 0. So, the answers don't always have to be positive. So, for starters, if we have absolute value 2x plus 5 equals 11, well, to get our 2 solutions, what we're going to do, we are going to solve one equation, 2x plus 5 equals 11. We're also going to solve 2x plus 5 equals -11. So, once you get the equation set up, it's probably going to be relatively easy to solve. All you have to do is solve each equation individually. To cancel the 5, we will subtract and then divide. So one of the 2 answers is 3. Over here, subtract the 5, so 2x equals -16. Divide by 2, and the second solution is -8. So that's why up here it was saying the answers don't always have to be positive. Here one answer was positive, one answer is negative. If we were to plug these answers back in, and this is where I want to kind of show you what absolute value represents. So 2 times -8 is -16, plus 5 is -11. Well, the absolute value changes a negative number into a positive. So that's why that solution actually works. So if we come down to example 2, absolute value 20 minus 9m equals 7. Well, again, all we're going to do is set up our 2 equations. 20 minus 9m equals 7. 20 minus 9m equals -7. And now from here, all we are going to do again is solve the 2 equations. Now, the one thing you do need to be careful about here, this is a positive 20. So we are going to subtract 9m equals -13. Now, from here is where we'll let you decide. When you divide by the -9, you can either leave your answer as a fraction, just, positive 13 over 9, or if you do prefer, certainly as a decimal 1.4 repeating. So one of our answers is, if we just round to a couple of places, 1.44. Now, if we come over here to this one, subtract the 20, negative 9m, and also be careful when that is minus 9m, that you do bring down a negative. Negative 7 minus 20, negative 27. And again, when we divide, negative 27 divided by negative 9 is 3. So, don't be surprised as you work through these. It's pretty common that at least one of the two answers will come out to a nice, neat integer, but it is very possible that one of them will end up being a little bit uglier of an answer, a decimal, something like that. So, again, just to kind of let you see how these do work, if I were to plug in the 3 again, 20 minus 9 times 3 absolute value equals 7. Well, for this one, again, when you take 20 minus 27, even though you have a negative inside your absolute value, it does give us positive 7. So, again, that's why absolute value equations work the way they do. All right, now, coming down to question number 3. Here is where we're now going to go back up to the statement up here. If C is negative in the original absolute value equation, there is no solution. If you were to try and solve this, you would, I'm going to actually show you that. If I add the 2, S equals 1, well, if we plug that back in, 1 minus negative 2 equals negative 1. Well, the absolute value of negative 1 turns into a positive, and 1 does not equal negative 1, whereas over here, if I have the negative 7, absolute value turns it into a positive. Up here with this one, I have the 11, absolute value turns it into a positive. So that's why in the future, if you see a question like this where the absolute value equals a negative in the original problem, you do not have to do any work at all. You can just tell us there is no solution. So there are the examples on the first page. Now just to come down and go through a few others. If you have something outside of the absolute value, for example, number 4 here, where it is absolute value d minus 3 minus 4 equals 2. Sometimes you see this and you say, oh, there's a negative 2, it's no solution. That's actually not correct on this one. First, we do need to get the absolute value by itself. So then we have absolute value d minus 3 equals negative 2 plus 4 is 2. Because our absolute value equals a positive, we are going to be able to solve this one. We're going to use d minus 3 equals 2 and d minus 3 equals negative 2. Add the 3 over, so d is 5 for one solution. Add the 3 over as well for the other one. d is positive 1. So, the solution combination, you can sometimes have one positive, one negative. Sometimes they will even both be positive values. For example, example 5, when I have 3 equals absolute value p minus 4 plus 9. Now, one thing that they have done that's a little differently here is they have switched the side where the absolute value is. It's not going to change anything that we do to solve this. Much like example 4, we are going to need to move the 9 before you set up your two problems. And when we do that, 3 minus 9 equals negative 6, equals the absolute value of p minus 4. Now, for this one, much like example 3, I'm just going to come back and put this directly above it. Example 3, we had an absolute value equal to a negative. Because absolute value turns everything positive, I cannot have absolute value equal to a negative 1. Right here, we now have an absolute value equal to a negative 6. Again, that is not mathematically possible. So this is no solution. The last two, we have variables on both sides. Well, what we're going to do, 3p minus 4 equals p. 3p minus 4 equals negative p. Only thing that changes is instead of changing a number to a negative, now we're changing a variable. Well, first thing that we want to do is combine our like terms. So I think it's easiest if you subtract over the 3p, negative 4 equals negative 2p, and divide. So one of our answers is p equals 2. For our other solution, subtract over the 3p, divide by the negative 4, and p also equals 1. So that gives us our two solutions there. Now, the one thing that you do need to do, because when you have a variable, it is possible you could get an answer that sometimes doesn't work. So I am going to actually plug both of these in just to check. So if I plug the 2 in, I get 6 minus 4, which is 2, the absolute value of 2 if it's positive to begin with. Sorry about that. Let me slide that over. So again, when I plug the 2 in, 3 times 2 is 6, minus 4 is 2. The absolute value of a positive stays positive, so that one works. When I plug my 1 in to the original equation, 3 times 1 minus 4 equals 2. Well, again, 3 times 1 is 3, minus 4, or actually that should be a 1. 3 times 1 minus 4 is negative 1. Because, again, it's absolute value, that does turn to a positive 1. So those answers do both check. So, again, if you have a variable on the outside, you do actually have to check both of your solutions. So, one final example, 4d plus 10 equals 6d. So I'm going to set that equal to positive and negative 6d. Now from here, subtract over 4d, so 10 equals 2d, divide by 2, and d equals 5. For this one, subtract over the 4, 10 equals negative 10d, divide by negative 10, and the other answer is negative 1. Now again, just real quickly, I am going to check both of our solutions. When I plug the 5 in, 4 times 5 plus 10 equals, when I plug the 5 in on the other side, I get 30. Now when I do that, 4 times 5 is 20 plus 10. The absolute value of a positive 30 remains positive. So our first answer checks. Now, when I plug in the negative 1, four times negative 1 is negative 4, plus 10 is positive 6. 6 times negative 1 is negative 6. Here's a good example. Absolute value leaves this 6 positive. We now have 6 equals negative 6. Well, you know, that obviously is not a correct statement. So it is possible when you work through problems where you have a variable on the outside of the absolute value. you may get an answer that doesn't work. Here the 5 did work, the -1 did not. On example 6, both answers did happen to work. So that's why if there is a variable on the outside, you do need to always plug those back in. There is a Schoology 6.1 assignment to go along with these notes. And again, we'll always have the afternoon help sessions as you guys are working if you do have any questions.